Hey, this is Mr. Molo with Puzzle Time 2.6. What do electrons wear on their feet? So it looks like another science joke here. All right, so we're going to look at a couple of these. Like number 1, I got x is less than, or the absolute value of x is less than 8. So remember, when I have my absolute value by itself, which it is in this problem, I can write my two equations. One just like normal, x is less than 8. And then remember, for my second one, I'm going to flip the sign and make my answer negative. So x is less than 8 and x is greater than negative 8. So it's going to look like letter O here. All right, then we're going to look at number 6. So I got 6x minus 12 is less than 42. So again, first step, get the absolute value by itself, and it is. 6x minus 12 is already by itself. So I'm just going to rewrite the problem. Then remember, we're going to rewrite the second problem, flipping the sign, so greater than, and changing that positive 42 to a negative 42. Then we solve it just like normal. So add 12 to each side, add 12. So I get 6x is less than 54. And I'm going to divide each side by 6, divide each side by 6. So then I get x is less than 9. Here, same thing. I'm going to add 12 to each side, except now it's a negative 42, so that's going to give me 6x is greater than negative 30. Divide each side by 6, divide by 6, so you get x is greater than negative 30 divided by 6 is a negative 5. So now here on number 8, we have something outside the absolute value bar. So remember, I'm not going to write my two problems yet. I need to get that absolute value bars alone. I need to get this 2x minus 5 alone. So first, I'm going to subtract 11 from each side. So now I get 2x minus 5 is less than or equal to 13. Now the absolute value bars are by themselves. So now I can write my two equations. So 2x minus 5 is less than or equal to 13. And then 2x minus 5 is, flip my sign, greater than or equal to, and change my answer to a negative. So negative 13. So remember, a lot of you still messed this up last time when we had equations. Do not write your two equations right away. You need to get the absolute value bars by themselves. So I'm going to add 5 to each side here. So I get 2x is less than or equal to 18. Divide by 2, divide by 2. So x is less than or equal to 9. And over here with the other problem, so I'm going to add 5 to each side, add 5. So 2x is greater than or equal to negative 8. Divide by 2, divide by 2. X is greater than or equal to negative 8 divided by 2 is negative 4. Then for this last problem, it's kind of tricky, so I thought I should do it with you. All right, so here, same thing, absolute value bar is not by itself. So I need to get rid of this plus 16 first. So I'm going to minus 16. So I still have the absolute value, so I still have the 9 on the outside. And then the absolute value of negative x plus 5 is greater than or equal to 0. Divide both sides by 9, divide both sides by 9. So I'm left with absolute value of negative 5 plus x. 0 divided by 9 has to be 0. Okay? This is kind of a tricky problem. I could pretty much stop right here because I know whatever's in this box has to be greater than or equal to 0. Even if x is 5, negative 5 plus 5 is still equal to 0. So when I have a greater than sign and a 0 or a negative number, or greater than or equal to sign, I should say. If it wasn't an equal to sign, it wouldn't be many solutions. Okay, so if I have a greater than or equal to sign and a 0 here, or a negative number, this is when it's going to be infinitely many solutions. Okay, there's no number in the world that you can put here for this x. Go ahead and think about it, that when you take the absolute value of that equation, that it's going to be less than or equal to 0. Okay, the lowest you can get is 5 minus 5, or negative 5 plus 5 is 0. That's still equal to 0. Anything else, you're going to get something that's greater than 0. So last time we were just looking for negative numbers. This time with absolute value inequalities, we're adding the 0 to it as well. Okay, so going back to our joke. Okay, what do electrons wear on their feet? They wear anti-shock socks. Get it? Because they're electrons and... Okay, science joke.